Hey guys, today we're going to be talking about systems of equations that involve quadratics, some nonlinears involved. Now what we know about systems in the past, a system of equations, we would have two lines and we would be looking for their point of intersection. That's the solution to the system. But now with quadratics involved, you're going to have a quadratic and you're going to have different possibilities now. Like the possibility that you intersect the quadratic with a line at two different points. So there'll be a possibility to have two solutions to a system. We still will have the possibility to have no solution, say the line doesn't intersect with a quadratic, or the possibility of having one solution. Having one solution, maybe the line goes right here and touches just at one point and then goes down. So that would be an example of like having one solution with a system of a linear and a nonlinear. And we're going to learn how to solve these algebraically today. So let's jump right in. Our first system that we're going to solve, we have the system with y equals negative 48x minus 31. And the second equation is y equals x squared minus 32x minus 16. So we're trying to find the solution to the system where these two lines are, or where these two graphs are going to intersect, the line and the parabola here. So to solve this algebraically, all we're going to do is, well, I'm going to look and see what we have in common. They're both y equals, so I'm going to set them equal to each other, meaning I'm going to use substitution. So instead of writing y in this equation, I'm going to write negative 48x minus 31. I'm substituting that down here. Equals x squared minus 32x minus 16. And now we're just solving an equation. So we're trying to find the values of x that make this equation work. Notice there's no more y's. That was the point of the substitution. So to solve a quadratic, you can use any method that we really want to. I'm going to get everything to one side and have 0 left on the other side. So to do that, we only have 1x squared, but I'm going to add 48x to both sides, so we should end up with plus 16x. And then I'm going to add our 31, and we'll end up with plus 15 over here. Now we can go through quadratic formula if we want. I always like to check and see if we can factor first. Factors of 15 that add up to 16, well, 15 and 1 work. So that means our values of x that solve this equation are x could equal negative 15 or x could equal negative 1. But to solve this system, we need to find out the y values that correspond with each one. So when x is negative 15, what's the y value? You can go back to either equation. I'll go to the linear right here. Y equals negative 48 times negative 15 minus 31. And when we go ahead and calculate this out, we're going to end up with 689. Really big number, but that's one of the points of intersection. And then we can look for the other point of intersection. And to do that, we would take when x is negative 1, we need to find the y value. So y equals, I'll go back to that linear, negative 48 times negative 1 minus 31. So positive 48 minus 31, we should get y is 17. So these are your two solutions. You can either have negative 15 comma 689. That would be one of the points of intersection. The other point of intersection would be negative 117. So when we went through and saw this, there would be 2 points of intersection. One of them would be negative 15, be really high up, and the other would be probably about here. So the parabola is going to go up higher. You'll have some line look like this, and those are your 2 points of intersection. So there's two solutions for this system. All right, let's jump into another one. So our next system that we have, let's see, we have the equation y is equal to 14x plus 3, and then we have the equation y is equal to 10x squared plus 14x minus 37. So again, if we want to solve, I'm going to use substitution here. 14x plus 3 is equal to 10x squared plus 14x minus 37. 14x's, you're going to get them to the same side, they're going to cancel. To get 0 over here, we would subtract 3. So we'll have 10x squared and then minus 40. We can divide both sides by 10 here. So you'll end up with x squared minus 4. And then we should notice that this is a nice difference of squares. So you're going to have x plus 2 times x minus 2, which means your values of x that solve this equation, x can be 2 and x can be negative 2. So x would be 2, x would be negative 2. Now to find the solutions to the system, I'm going to go back to that linear equation and we'll say y equals, well, if we're using the 2 first, y equals 14 times 2 plus 3. So y equals 28 plus 3. So one possible solution is when x is 2, y can be 31. That'll be one point of intersection between these two. And our other would be when x is negative 2. So y equals 14 times negative 2 plus 3. So negative 28 plus 3. So y can be negative 25 as well. And that would be if x was negative 2. So our 2 points of intersection are right here. We'll intersect at 231 and negative 2, negative 25. I will do one more with linears and in quadratics. Actually, we'll do a couple more with linears and quadratics, and then we'll see one with 2 quadratics. So let's take our next system here. We have y equals negative 3x plus 6, and y equals 1/2 x squared plus 2x minus 22. So again, we're trying to figure out the 2 points of intersection, or maybe one, or maybe no points of intersection between these two graphs. So if we go ahead and use substitution again, we're going to have negative 3x plus 6 equals this whole right side, 1/2 x squared plus 2x minus 22. I'm going to get everything over to this side first, so we'll get a 0 on the left. We'll still have that 1/2 x squared. We're going to end up with plus 5x and then minus 28. Then to make it a little nicer, I'm just going to multiply everything by 2. So you'll end up with x squared plus 10x minus our, if we double this, we're going to end up with minus 56. And now we're looking for, see if we can factor. So try to think of factors of 56 that will add up to 10. And let's check. So I get 14 and 4. We know that one has to be positive, one has to be negative. So if we have a negative 4 and a positive 14, those would be two factors that multiply to be negative 56. And when you add them up, you're going to get the positive 10. So that means x could either be negative 14 or x could be positive 4. And now we just need to figure out the corresponding y values. So one point of intersection, if x is negative 14, so if x is negative 14, let's find the y value. Y would be negative 3 times negative 14 plus 6. And when you go ahead and simplify this, you should get y is equal to 48. So one point of intersection is negative 14, 48. And our other point of intersection would be where x is 4. So let's go ahead and do y equals negative 3 times 4 plus 6. X is 4. So you'll have y is negative 12 plus 6. So you should get y is going to be negative 6 here. So there's your two solutions. We have, where's a green? There's a green. One point of intersection is negative 14, 48. The other point of intersection is for negative 6. I will do one more, and then we'll talk about one with a couple of quadratics. So our next system, we have y equals x squared plus 4x plus 5. and y equals 2x plus 4. I'm going to go through the same process here. I'm going to say 2x plus 4 is equal to x squared plus 4x plus 5, just substituting in. And I want to try to isolate, so I'll get 0 on one side. To get 0 on this side, we'd have to subtract 2x, so we're going to end up with plus 2x on the right, and we're going to have to subtract 4, so we'll end up with plus 1. You might notice this. If you don't notice, you would go through factoring, but this is a perfect square, and it's x plus 1 squared. If you didn't notice, in trying to factor, you would end up with x plus 1 times x plus 1, which would jump out to you as something times itself is being squared. So for here, we only have one possibility. X can be -1. And if x is -1, so we're trying to find what y is when x is -1, y would be -2 plus 4, so y would be 2. So right here is your point of intersection. There's only one, which means for this, we have an upward opening parabola, 2x plus 4. So our point of intersection would be like right about here. It's only going to intersect at one point. Alright, let's do one with a couple of quadratics to see how we could solve them, how we can deal with these nonlinears. So our last one of the day, we have y equals x squared plus 8x minus 3, and y equals -x squared minus 5x plus 12. When you have more than one parabola, there's a few possibilities. Actually, there's a lot of possibilities. You can have like one parabola opening upward and one downward, like what we have here, in which case you could see something like this, where they're going to have 2 points of intersection, one opening upward and downward. You also could have them intersect at one point or no points. You could have them look like this. They won't intersect at all. So no points of intersection. So you could have 2, 1, or 0. And they could still intersect if they both open the same way. Like if you had a parabola opening upward and then one that was more narrow opening upward, they still could have more than one point of intersection. They also could intersect at exactly one point. A couple of parabolas like this opening in the same direction, or two parabolas opening in the same direction could have no points of intersection. They could look like this. So, a lot of different possibilities, but what we have here is one opens upward, one opens downward, so either there's going to be 1 point, no points, or 2 points of intersection. Alright, so let's go ahead, take this system, and I'm going to substitute. So we're going to have x squared plus 8x minus 3 is equal to -x squared minus 5x plus 12. So here I'm going to try to get everything to the same side. So I'm going to add x squared here to the other side. We'll end up with 2x squared. We're going to add the 5, so we'll have 13x. And I'm going to subtract the 12, so minus 15 is equal to 0. And now we got to try to find this, or you could fall back on the quadratic formula if you want. I'll go through, actually we haven't done quadratic today, so let's do quadratic. So the values of x that would make this work, and let's actually go up high. So it's going to be the opposite of b, minus 13, plus or minus the square root of b squared. That's 169 minus 4ac, so a times c is -30, times 4 is -120, so we're going to be adding 120. All of this over 2a, so all over 4. Let's go ahead and get this out of the way and simplify. So -13 plus or minus. If we simplify inside of our radical, 169 plus 120, we get square root of 289 all over 4. Square root of 289, if you don't know, it's a perfect square. It is the perfect square of plus or minus 17 all over 4. So we have two possibilities here. We have the possibility that x is -13 plus 17 over 4, and we have the possibility that x is negative 13 minus 17 over 4. Over here, negative 13 plus 17 is 4 over 4 equals 1. So one possibility is x is 1. That'll give us one of the points of intersection. And over here we'll have negative 30 over 4. And that should simplify to, let's see, we're going to end up with 7.5, but a negative 7.5. Okay, so those are our negative 7.5 or 15 halves if you want, like 15 halves. So those are our two possibilities for x. Now we just need to find the corresponding y's for them. So if you want to find the y's, you got to substitute. I like the top one a little bit better. So when x equals 1, we need to find out what y goes with it to find that point of intersection. And we would just say y equals 1 squared plus 1 times 8 minus 3. 1 squared is 1, plus 8 is 9, minus 3 is 6. So one point of intersection is 1, 6. So I can take that away. And our other point of intersection, we have negative 15 halves. So let's go ahead and say negative 15 halves. We want to know what y goes with that. So let's make some room. So y would be, well, negative 15 halves squared plus 8 times 15 halves, or negative 15 halves, minus 3. 15 halves squared should be positive 225 fourths. We're going to end up with a minus because we have the negative. 2 and the 8 kind of cancel out here, so 4 times 15 is minus. We're actually going to end up with 60, but I'm going to write that as 240 over 4. This did equal 60. I want to get it in the same denominator. And then minus 12 fourths here. So when we go ahead and do this, 225 minus 240 minus 12, we're going to end up with y is equal to negative 27 fourths. So here's our y value for our corresponding x, and if we did decimals, it would be 7.5 and negative 6.75. Those would be the decimal values here. But those are our points of intersection, 1, 6, which is a little bit nicer, and either one of these two. Alright, and that's all we have for the day. Go ahead and try some of these on your own. Have a nice day.